that Python has, their intrinsic types are objects. But for the language to be truly powerful, we need to be able to define our own classes. And so our own objects. And so a class is how Python allows us to extend the basic objects in Python by creating new types of objects. And since objects consist of attributes and methods, defining a class means defining the attributes of that object and the methods. So the adjectives will be the variables, and the verbs will be the methods or the functions. So a class is a type of code block. So it's defined by the keyword class, and the syntax looks very similar to, say, a definition of a function. We have the keyword class, then we have what we're going to name this class, and then we have what type of Python object we're going to inherit from. And then we have a colon, and then we have an indented code block. The definition of the class ends when the indentation level returns back to the indentation level that was present at class. So all classes must inherit from some more basic class, and the most basic class in Python is called object. We can inherit from an integer, a list, a dictionary, any existing type of Python object, but we must inherit from something. So let's go through an example here, defining a class with a pet shelter example. So here we define a class that's named shelter animal, and it inherits from object. We have our colon that marks the beginning of our indentation. And the first thing we're going to do is we're going to define a magic method that's called a constructor. And this constructor has the special syntax _init _. And it's a function, and it takes a set of arguments. Now for these Python objects, these methods, there's always the first argument of a method is a variable that refers to the specific instance of the object. And by convention, this variable is named self, but it does not have to be named self. That's just a convention. In other languages, you'll see like the variable named this. We could just as well use this as we do self, but by convention, we use self. So it takes a positional argument self, and in this case, I provided a variety of keyword arguments. So I'm going to say what kind of species it is. It'll default to dog. An age, which will default to 0. A name, which I'll set at none. An ID, which will be set equal to 0. You see ID is showing up as green, so it's probably not a good choice because it's a name that has meaning in Python. Whether it's altered, which I'll assume is false, and the sex, which I'll assume is female. Okay, so then what am I doing? So then in this constructor, I am going to assign to the specific instance referenced by self of this class, I'm going to create an attribute that in this case is named a variable species, and I'm going to set it equal to the variable species that I passed into the constructor. And so on, self.age, self.sex, self.name, self.id, etc. I'm also creating some variables that don't associate with anything that I pass into my constructor. So I'm creating an attribute problems, which I'm setting equal to an empty list, an attribute medical clearance, which I'm setting equal to false, and an attribute comments, which I'm setting equal to an empty string. Okay, so that's my constructor. I'm going to define some additional methods, such as I'm going to define a method setName, which is going to take as an argument a string, and I'm going to assign a new name to the object based on what I pass in here to name, and a similar function getName, which I'm going to use to return the name of the object. And then I'm going to have a method addProblem where I pass some problem in, unspecified type, and append it to my self.problems. Now this is kind of a confusing, this will take us a little bit of practice to get used to, that this idea of creating the self, and we're attaching these attributes to this variable self, self.species, self.age, etc. All right, so let's define another method that goes with this, this class. And so we'll define a method called adoption match. And what it's going to do is it's going to take, again, it's a method of the class. So it takes as a first argument self, and it takes another positional argument features, which in my docstring I say is an iterable object containing problems the adopter is concerned about. And so what we're going to do is we're going to loop over these features, and we're going to ask, is that feature in the list of problems that we've created for, so here problems is an empty list. We have this add problem that appends something to the problem list. And in adoption match, we are going to ask if any one of these features that the adopter or adoptee is concerned about is associated with that patient. I'm just going to copy this up here so we can actually create this class. All right. Now, I'm using this method, adoption match, to access and ask questions about the attribute problems. Why wouldn't I just directly access self.problems for the class, the instance? And this goes back to the idea of encapsulation. I don't want the user of this class to ever interact directly with an attribute. I want them to interact through the attribute through the methods. And there's a variety of reasons for this. And to be honest, I don't always follow them because I get lazy. This is, again, the concept of encapsulation. I started this class with using a list for problems. I may want to change that to a dictionary. Well, the user of it on adoption match doesn't necessarily need to know that I've changed from a dictionary, from a list to a dictionary. So we're using adoption match rather than directly accessing self.problems to follow the principle of encapsulation. And there's other things. I can do validation. I can, there might be only certain types of problems that I want to to be associated with self.problems. And so when the good design principle is if we have an attribute, we want the user to interact with that attribute through a method that's associated with the class. All right, so let's evaluate that cell. And now let's create an instance of a shelter animal, Rob. Okay, and then we can print Rob. And you see we just get this shelter animal object, etc. And that's because we haven't defined the magic methods that are associated with the print. And so we are using the very basic print method that's inherited from object, which basically just shows what the class is, where it's defined, and where that particular instance of it is located in memory. Okay, let me take, let's think about a more complex adoption method. And so here, we're adoption match 2, we take a set of features, and what we're going to do is we're going to call the adoption match and see if there's any of those problems associated with this animal. And then we're just going to ask some questions about the animal specifically, like, does it have medical clearance? Has it been altered? Is this age greater than 4? Well, whether 4 is weeks or months, we don't have that. We're kind of weak here on the metadata. If these things are all true, then we return true, else we're going to return false. I need to point out something specific here. When we call adoption match, which is a method that's associated with a particular instance, and that's why we use a self.adoption match, you see that when we defined adoption match, it takes as a first argument self, but when we call adoption match, we don't provide self. So I don't know how to explain why, but we define a function with self as the first argument, but we don't use self when we're calling that method. All right, so now I got a new definition of shelter animal that has that in there. Again, self is an implicit argument. It's always present but not explicitly provided when you call it. Now let's create another shelter animal, which we'll call Randy. In this case, we have, we're going to say that it's a dog. We're going to provide an age, sex, a name, an ID for it, and say that it's been altered. And so now, let's go through. So we print it again. We're just getting very similar, that basic print statement where the class is defined. Main is the current program. This is an instance of shelter animal, and that's its location in memory. Here, I'm showing that even though I'm telling you we don't want the user to explicitly interact with an attribute, in this case age, we can, as I've defined it. So here I'm setting, when I created Randy, we set the age equal to 3. And let me just put a cell up here so we can verify that. Age is 3, and I'm going to set the age to 15. So I am able to directly interact with those attributes, although I don't want to. Another point is here, if you look at our definition of the shelter animal, there's nothing about an attribute favorite food. But there's nothing in Python that stops me from creating a new attribute for that object and assigning a value to it. So in this case, I'm creating a new attribute, favorite food, hummus, and that gets printed out. Now the other instance that we created, Rob, if we look at what Rob's favorite food is, we'll get an attribute error because that instance doesn't have an attribute favorite food. All right, so we can add some problems, cats and hips, and then we can ask questions about whether Randy is ready to be adopted. So in this case, we're using the getName method to return the name, and then we're asking the simple adoption match. So Randy, in this case, the person has birds, concerned about cheese. Those birds and cheese are not issues for Randy, so adoption match would come out as true. If we use the more complicated adoption match algorithm, then we get a false, and that's because Randy has not been altered. So if I do randy.altered, that'll be it. Whoa, it's true. Well, check into that. All right. Again, here's just another one, Argos. We can ask the same problems. And in this case, we can see that Argos is not an adoption match. And I sure think that he should be, given what we've defined. Well, something to look over.